Jai Hind everyone, my name is Amrita Bhatnagar. Today I am going to give the lecture on the processor organization, which is the first unit topic. You can see here we have these main outlines of the this lecture. First one is the central processing unit, then different type of CPU organization or processor organizations we will discuss. Firstly, this is a major component of CPU. So everyone is aware about it. CPU will use in the computer to execute the instruction. So we have major component of the CPU is register set, arithmetic unit, and control unit. So in the case of we use register set to store the instruction data and different type of operations. So, and in the arithmetic unit, we will perform all the micro operation, and with the help of control unit, we supervises the data transfer among the register. So, we can say that register is the memory element which store the data, and ALU is used for the performing the operation in the CPU, and control unit is the overall responsible for the operation in the CPU, or we can say that control unit control overall operation of the CPU. Yeah, so you can see here these three components here: register set, ALU, and control unit. So firstly, when the instruction will fetch from the memory, the register set are used. In the register set, we have an instruction register where we have fetch instruction, and then this instruction will be executed using the ALU or arithmetic unit. Then the role of the control unit will be started. Control unit will be active at the whole process and control overall operation of the CPU. It will control overall operation of the CPU. So, in this case, we will see the what is the major role of the control unit. In this lecture, we will see about it. Now, different type of CPU organization. We have mainly three type of organization: single accumulator, general register, stack. Some CPUs combine features from the more than one organization type. So, hybrid type of organization also possible here. In the single accumulator, we have only one register, which is known as a accumulator. In this case, we have accumulator, and we will work using the only one register accumulator, and we will use one address instruction here. And in the general register organization, we have more than one instructions. So, so more than one register. So, that's why it is known as a general register organization. In this lecture, we will discuss about the general register organization, how it will perform when we have more than one registers. And the next one is the stack organization. In the stack organization, the register will be organized like a stack, and it will work like a stack, and the insertion and deletion operation is also performed like a stack in this case. And last one is the hybrid organization, where we can have two different type of organization combined. Now, first is the single register or accumulator organization. This is used in the basic computer. So, we can say that basic computer is a good example of single register. Accumulator is the only general purpose register. So, accumulator is only one register which we have in the single register, and then the name of this register is accumulator. This is the processing register. Everything or every operation will be performed in the accumulator only. Next one is the general register organization, used by most modern computer processors. So, this organization is used by the modern computer processor because in this case we have more than one registers. Any of the register can be used as the source or destination for the computer operation. So, general register organization is that organization where we have more than one register. Now, last one is the stack organization. In the stack organization, all operations are done using the hardware stack. So, register will be organized in the form of stack. For example, an OR instruction will be pop the two top elements from the stack and do a logical OR on them and push the result on the stack. What it means, the registers are organized in the form of stack, and the deletion and insertion operation will be performed like when we have in the stack organization, like pop and push operations are performed like the stack in the hardware also. So, this is known as a stack organization. Now, you can see here this is a diagram for the general register organization. In this case, you can see this is the diagram. Now, you can see here we have more than one register, because in the general register organization we have more than one register. So, in this case we have 7 registers to store the data. So, we have the 2 multiplexers also here. Now, what is the use of this multiplexer? We have 2 buses here, A and B, A bus and B bus. So, all these registers are connected with the multiplexer. The size of the multiplexer is 8:1. 8:1 means 8 inputs are there and 1 output is there. So, all the registers are connected with the multiplexer. So, we have 7 registers, 7 registers are connected and 1 input is connected with the input. This input is used for the input from the input device like keyboard. When we insert an input from the user side or using the keyboard, then this input will be utilized. Now, how it performs? So, you can see here, if there is a operation, for example, if we are going to perform a operation A plus B, what will happen in this case? For example, the first operand A will be stored in the R1 and second operand B will be stored in the R5. So, all the operands are stored in the registers. So, what will happen? The A operand will be selected from the multiplexer 1 and B operand will be selected from the multiplexer 2. So, we have A on the bus and we have B on the bus. Now, the work of the ALU is to add the content of the A and B, or add the values of the A and B. So, we have to give some input or some selection lines here so that it can perform addition operation, because ALU can perform many operations, but in this case we have to perform only plus operation. So, we have to give the code or some value so that ALU can perform addition here. So, this is a role of the control unit. Control unit will give this input. You can say control unit will give the inputs to the ALU to perform the addition. So, this input will be given by the control unit by the help of control word or control signals. Now, you can see next in the case of multiplexer also. So, we have to select, in this case from the A bus, we have to select R1, content of the R1. So, we have to give 001 here. So that we can select R1 data, and in this case we have to select R5. So, 101 should be the selection line value of the multiplexer here. So, these all are the part of the control word, because these all signals are generated by the control unit. So, we can see here the ALU will perform only the operation, but the overall control of the operation will hold by the control unit. So, in this case you can understand the major role of the control unit. So, these operations, for example, input for the ALU, selection lines for the multiplexer A and selection line for the multiplexer B, these all are the things which is provided by the control unit only. Now, you can see here when the ALU will add this A plus B, and now this A plus B have to store into the another register. Again, we need a 3:8 decoder for this purpose, because we have to store this result into the register. For example, if we want to store the result into the R3, now what will happen? Because the these output is connected to the all register, only the load input will be active of the R3, because we want to store the data into the R3 only. So, what will happen? You can see here, this is the decoder. 3:8 decoder is there, where we have 3 inputs and 8 outputs also there. So, if we want to give the 3, select the 3, so we have to give the input into the input to the decoder, so that it will active the load input of the R3 only, and other register will not take the input from the ALU. Only the R3 will take the input. So, we have here 3:8 decoder. What is the role of decoder here? Decoder will always perform the always give the output, one output 1 and other output will be 0. So, if we have 8 outputs, so only one output will be 1 and other output will be 0 here. So, only the output of the decoder of the R3 load input will be 1 and other will be 0. So, data will be goes into the R3 only and other inputs will be 0. So, load input of the R7, R6, R5, R4, R2 and R1 will be 0. So, this register will not take the take the input from the ALU. Only R3 will take the input from the ALU. So, in this way, the A plus B instruction will be performed in the general register organization. So, I am going to repeat again. General register organization means more than one register. In this case, we have 7 register. We have more than one register. So, in this case, we are performing the A plus B. Now, again, the major role of control word is there. We will see how the control word will be generated here. You can see here. For example, we want to perform R2 plus R3. Okay. And the content of R2 plus R3 is transferred into the R1. So, now we have to perform the or design the control word. So, this is the format of the control word where we have selection line A, selection line B, selection line D and operation. So, we need to arrange these values in this form. So, firstly we will see here we have selection A, mux A selector selection A, put content of the R2 on the bus A, mux B selector B, put content of the R3 on the bus B, ALU operation selector, perform arithmetic addition because we are going to perform addition R2 plus R3. Fine. And then decoder destination selector will be SELD and transfer the content of the output bus into R1. Okay. So, how we will create the control word? You can see here. Okay. You can see here this is the SELA, SELB, SELD and OPR. So, when we are performing the designing the control word, so this is the table. You can see a 0, 0, 0 where we have input connection and the 0, 0, 1 we have one R1 register connection, 0, 1, 0 R2 connection, 0, 1, 1 R3. In this way we have connection of R7, R1 to R7 connections we will have. Now we want to design the control word here. So, we can see here. So, firstly we will need to SELA, selection line of A. So, in the selection bus A we have R2. So, you can see here the R2 is here. We can see here R2, the code of the R2 is 0, 1, 0. So, this is the SELA. Okay. Now, next is the SELB. In the SELB, we are giving the value of R3. So, the code of the R3 is 0, 1, 1. So, we will have here 0, 1, 1 SELB. And in the last one SELD. In the SELD, we will have the decoder selector input. So, this content addition, after the addition, content is transferred into R1. So, we will have value here, here we will have value here 0, 1, 0, 0, 1 because R1. Destination register is R1. Now, last one is the operation. In this case, operation is addition. So, we will keep the code of the operation. So, this is the 3-bit code, this is the 3-bit code, this is the 3-bit and this is the 5-bit code because we have my ALU can perform 2 raised power 5 operations. So, for example, 0, 0, 0, 0, 0, 0, 0 is the code for addition. So, we can have here 0, 0, 0. If this code is different, then we can give here different code. So, what it means, why we keep the 5 bits for the operation because our ALU will be having 2 raised power 5 operation, and only one operation will be performed by this instruction. So this is the by the help of this table we can perform, or we can design the control word. This is known as a control word, and this control word is designed by the control unit. The whole sole responsibility to generate the control word is control unit. So control unit is a major part of our processor organization. Fine. So this is, in this way we can generate control word, and this control word will generate the control signal. Okay. So in this way we can generate the control word. Thank you.